Huh? Because the explanation is already given.
Yeah, yes, sir.
One minute. We put
now,
for
pendulum bob, everything is arranged for ISO test. Degree. So this is the striker for the charpy. So now you can observe we are removing the.
this is
Now pendulum bob, everything is arranged.
we have finished ISO test with some changing the arrangement. You are doing charpy test similar to the ISO test already we have conducted. Just if you see the video, that is we can understand.
For ISO test.
Okay.
Charpy test, you have to keep it inclined. This now it is in the horizontal position. The complete bob you have to rotate and you have to mount it at certain angle, that is 135 degrees. So this is the striker for the charpy. So now you can observe you are removing everything. You are mounting it.
Is it visible and audible? Hello? Is it visible and audible?
Yes, sir.
Okay.
Yes, sir.
For charpy test. Now it is set for ISO test. Including strikers, you have to change.
No.
The screws are there, you have to remove that screw.
But ಅವರು ಇದ್ದಾರೆ ಓಡಿಎಂ ಅಟೆಂಡ್ ಮಾಡ್ತಾರೆ.
Now this striker is for
ನನಗೆ ಕ್ಲಾಸ್ ಇದೆ.
adjusted for
ಐಸೆ HOD ಗೆ ಹೋಗಬೇಕು.
charpy. No,
ಓಡಿಎಂ ಇದ್ದಾರಾ?
you remove the cage in the striker. These strikers are mounted tightly and rigidly so that there should not be any slackness or looseness. So you can observe how the striker is removed. But when you are removing the striker, there is a safety bracket that should be mounted. Extreme precaution should be taken when you conduct the impact testing.
Those who joined already, you have finished ISO test with the same machine with some arrangement. You are going to conduct charpy test. Charpy test, the striker is inclined. There's one point you have to remember. The striker, in the sense, this complete pendulum bob is inclined. There's one point, and specimen is different. That is available in the manual. We show the specimen also. Third one is striker is different. You have to change the striker. And fourth one is where exactly the striker hits the specimen. Those are the four differences you have to remember or you have to observe. So when you're seeing the videos, but all other procedure remain same. Formula is also same, and no only one small calculation. So energy observed is given. We can get it from the experiment that divided by the cross section area that gives the impact strength of the material, same as isotope, except the position of the pendulum bob.
The specimen for the impact testing, then it's changing the setup from ISO test to charpy test. This is the striker used for
So you can see the photo. This is the striker used for ISO test. Now you have to put the striker for the charpy test. First phase, you have to change the striker. The next step, you have to change the position of the pendulum bob, initial position of the pendulum bob.
ISO test. Now you are mounting the one more striker. This is the striker for charpy test. So now you are mounting this specimen into the pendulum.
Hello. One is sir.
Already we place the striker in an appropriate place. Now you are putting the screw and you are tightening it.
In the examination, sometimes you have to change the striker as well as you have to change the position. I think before your final examination, one more definitely final examination is on regular offline examination. Before that, you have to come to the lab. You have to practice yourself because of time and other things will be given. Don't worry about that part. But in the examination, examiner may instruct you to change the striker as well as to change the position. So that's why I'm showing the complete detailed video. So, okay, sir.
Specimen.
2:30 close ಮಾಡ್ತೀರಾ? ಮಾಡ್ಬಿಟ್ಟು ಹೋಗ್ತೀನಿ.
So now you have to remove this arm. You have to mount it to different position. Now you fix the striker for charpy. Now this position to be changed to 135 degree. 135. Right?
Now it is in the horizontal position. You have to rotate. You have to remove this arm. You have to incline to 135 degree for charpy test. For isotope, it is horizontal. Charpy 135 degree.
Now it is 90. Now it is. There is a separate mounting nut and screw and nut. Screw is available. Now you are removing it. Of course, you have to mount it on inclined surface. Charpy, it is inclined, is 195 degree. Already two screws are removed. Another.
It's only the remove of screws. The same procedure is follow for all 4 screws. Just speed up that.
It's the same position. Angle. now you can see this lever, you have to mount it at inclined angle. This is there. After this is after 2 pins is there. Same, it's the same position. It pins is there. Align it. Now this is charpy position, 135 degree.
That again, after keeping at 135 degree, again there are 3-4 screws are there. Again, same procedure you have to follow. I will go a little bit fast here. See, now we can see it is almost 135 degree. It is mounted.
So I have tightening the screws.
The same tightening of the screw, there is no much changes.
It will take around 12 seconds.
Now the complete arm, horizontal arm is inclined. Now your pendulum bob is here. That you have to mount it here. Then you have to drop the pendulum bob so that specimen will break once you drop the pendulum bob.
For charpy test, when earlier it was meant for ISO test. Now, next step is you have to mount the specimen. Mounting the specimen is slightly different. Specimen length 55 mm, 10 into 10.
Complete dimension of the specimen, how the specimen is mounted, each and every details are there in schematic sketch in the manual. You can go through the manual also.
This is a U notch, 5 mm depth. After 10 into 10, 2 mm is cross section. 2 into 5 cross section will calculate. After this is 135 degree, and this is a pendulum. Pendulum will lift it down. First, after stopper.
So especially when you lifting the pendulum, there is a locker in there. You have to mount the locker. Otherwise, it may fall at any time. There is a one hand lever. If you operate that lever at any time, it may fall. That's why there is a safety locker in there. I hope it is audible and visible. Yes or no? One of you respond, please. Yes or no? Is it audible? Visible? Video?
Sir, it's visible, sir. Audio is not clear.
Audio, that is okay. That anyhow, I am giving the explanation. That's only the mounting arrangement. There is a echo in the room. That's why there is audio is not clear. But I will explain that there are two scales. The inside scale is for the charpy, and outside scale is for inside scale is for eyes that already we have used, and outside scale is for the charpy test. The same scale what you have done in the previous class, there is slight difference.
So both maximum position you set it is a charpy now. You set it to maximum 300 joules. Don't set this 0. Maximum you set it. After specimen before isotype vertical position, not perpendicular direction. Charpy opposite. Horizontal position, not opposite direction. See, one slot is there. One slot you will fix it specimen. That side. Vertical position, not perpendicular direction.
Here, in the case of charpy test, you are mounting the specimen in the horizontal position. The striker will hit the specimen. It is behind the notch, opposite to the notch. That is the only difference.
Charpy opposite, horizontal position, not opposite direction. See, one slot is there. One slot, you fix it specimen. That side, you put it. That side, you put it. So, material already.
So that is after mounting, just you have to remove, you have to drop the pendulum probe similar to the ISO test. You have to note down the values. So that part it is not recorded here, but it is same as the ISO test. Now we have already finished compression test for brittle material, and you have to finish one more compression test for the ductile materials. Formulas are same, the plot is same, then equipment is same, the indicator, the observation is also same. You have to note down initial diameter of the specimen. Then after specimen compression, you have to note down final diameter and initial length of the specimen and final length of the specimen, so that we can find out what is the total percentage of elongation and percentage of increase in cross section area. Then same video I'll show. It is exactly the same as what experiment you have finished in the previous class. That's for the brittle material. The brittle material, it fractures fastly, but ductile material, it undergo huge amount of plastic deformation. Those things already you have explained in the previous almost. You have used UTM for bending test. We have used UTM for tensile test. Already we have finished one more test using UTM for this compression test for brittle material. This is the fourth test you are conducting using your UTM. That's why I not explain the UTM once again. Straight away we go for conduction of compression test on ductile material. Initial diameter you have to note down, final diameter you have to note down. Initial length you have to note down, the final length you have to note down, and force you have to note down. Force and corresponding deformation is the same as all three previous tests.
Initial diameter and initial length. So, first initial diameter MSR 10 CVD 20 divisions. Initial length MSR 14 CVD 30 divisions. Initial length you take after put it compression pad. Put it again. So after position, first this is right side of close. Left side not close, again switch on, again left side not close.
There is a cross set. This is the cross set. You have to move the cross set so that it should touches the specimen. Already you have used the same up and down button. By using up and down button from the control panel, you have to move the cross set down so that your top compression pad, this bottom where a workpiece is placed, that is the compression pad. So, and top compression pad should touches the workpiece. Then you have to move the stop up and movement of the cross set. So now specimen is placed between top compression pad and bottom compression pad. Then you have to apply the hydraulic source. Now you are not using the hydraulic source, you are using the motor that will move the cross set up and down, similar to previous three experiments.
This is cross set downwards.
So when you moving the cross set up or down, you have to switch off the hydraulic system. Now it is the hydraulic system is switched off.
Just 1 mm, 2 mm gap to just.
Now you are moving the hydraulic the cross set in the downward direction by operating up and down button.
1 mm gap to adjust. After switch on this system.
Now we can see the top cross set. Below the top cross set there is a compression pad. It touches the workpiece. Then you have to stop up and down movement of the cross side. Now you have to switch on hydraulic system to apply load.
After switch on this system, means this button can press it, slowly release. The point 1, point 2, point 3. Slowly release. Slowly apply the load.
Now you are applying the try to apply the load by hydraulic system. We can see there are two values you have to note down. One more is displacement and one more is load. So you are applying the load. You have to noting down corresponding displacement. It is exactly similar to the previous three tests already you have conducted. One is tensile, one more is bending, one more is the compression test for the brittle material. No difference. Now your hydraulic system is switched on. The load is applied to the you are applying the load to the specimen. Because at the initial level, there may be this your displacement shows some readings as well as load indicator may also show some reading. For that, you have to set that to 0. Initially, it may show some because by default there will be some value may be displaying. So once hydraulic system is started, when this a slight amount of load is applied, then you have to set displacement is equal to 0, the load equal to 0.
This is a load, this is a deformation. So first 0.
There is a reset button here. So this reset button, if you want to press, so it will reset to 0.
0.1 kilonewton, 0.2 so displacement 0.1. So after your reading, you will take 1 kilonewton displacement, 5 kilonewton displacement, 10 kilonewton displacement, up to 50 to 60 kilonewton will take load versus deformation. Now specimen is compressing. You can see the increase in load. Slowly load is increasing, and deformation is also almost 6. So now the load versus deformation.
There is no changes here. Just you are applying the load. You have to note down corresponding the load as well as the displacement. The load versus displacement value will be given similar to bending and tensile test. I'll put it in the group for B1 and B2 batches. You can use those for plotting the graph.
You can observe that the bottom portion of the specimen is placed between two connected to the hydraulic.
Just you are applying the load. I'll just go a little bit fast.
So now we can see the load is around 32 kilonewton. The corresponding displacement is around 2.9. So you can observe as load increases, the displacement is also increases. Now the specimen is compressing. You can observe the length is decreasing. So it is totally compressed and punched. Now you can see the compressed specimen. So you can see the compressed specimen. So now this is a compressed specimen. We can observe. This is the compressed specimen. This is another side of the compressed specimen.
Now you can see, I think you're not able to see, this is the compressed specimen. You have to note down the final diameter as well as final length. I think already you have seen, I think. This is the compressed specimen. In the case of brittle material, it fractures, but in the case of ductile material, it not fractures. So at some point, so load is gone increasing. So in that particular point, you have to stop application of the loads. I hope, I think many of them are not completed your record. So I've gone through it, only few are uploaded. Those who are not uploaded, please upload it. So immediately after the test, I expect Sunday, within Sunday evening, all this, if those are not uploaded, you have to finish it within Sunday. Otherwise, you'll do the mark. I'll give you sufficient time. So after finishing the test. So those who are not enter your USN number, please enter. Enter your USN number. I'm going for stopping the record. Just enter your USN number. Those who are not entered, because I'm going for stopping the recording part. Once I stop, so it is your USN number not appear, because after few minutes or few minutes you get the complete recorded video as well as your USN number as well as name. So whatever you chart, so that everything comes in the record. But once you stop, afterwards you enter your USN number, you don't get. That's why complete the record, and values for compression test, the observation, load and deformation value, I'll put it in your group. You can get the values from the group, and you have to draw stress strain diagram. That stress strain diagram for the compression test, you try to finish at the earliest. I think I expect around Saturday evening or Sunday, within Sunday evening, you have to complete the stress strain diagram for the compression test. You have to upload that. Uploading time, everything I'll give you. But those are not uploaded your record for the first set of experiment that was conducted between first test and before first test, you have to submit at the earliest. If you submit late, you may lose the marks. Then for second test which was conducted after between first test and second test, so I'll create one more assignment space in the Google Classroom, and that particular space you have to put all those information. I'll put it in the group. So now those who are entered your USN number, we can leave. Now I'm going to stop the recording, and as well as I'm leaving. Today those two are very simple experiment, and similar type of experiment is conducted in the previous class. Which slight variation is the variation. Already you have seen those variation in the video. If you have any difficulties or doubt, I'll clarify in the next class. So okay, thank you.